Now I will be discussing the inorganic chemistry part of plus 2 chemistry. Now there we will start first with metallurgy. The naturally occurring compound of a metal is called mineral. Now any compound of a metal occurring in nature may be called a mineral. Now those minerals from which the metal may be extracted, separated easily and economically are called ores. Now for example, gold is present in seawater. Now suppose we are able to get gold from a jewelry shop, 1 gram of gold from a jewelry shop for rupees 5,000, and let the expenditure for isolating 1 gram of gold from seawater is 10,000 rupees, then we will naturally buy 1 gram of gold from a jewelry shop rather than separation of gold from seawater because it is costlier. So that is the underlying principle behind economy, so that the isolation should be cheap, should be of less expenditure of money. Now the processes also should be less economic, and minimum processes should be adopted for isolation of the metal from the ore. So all minerals cannot act as ores. All ores are minerals, but all minerals are not ores. Now coming to the ores of some of the ores of some metals. For example, aluminum, the important ore is bauxite, having the formula Al2O3XH2O, where X is approximately equal to 2. Now there is another ore of aluminum that is called the kaolinite. It is Al2OH 4 times Si2O5. Now I am attempting to write the structure of kaolinite based on the valencies of silicon, aluminum and oxygen. Now silicon with a valency of 4, that is 4 bonds around silicon. Aluminum with a valency of 3, that is 3 bonds around aluminum. And oxygen with a valency of 2, that means 2 bonds around oxygen. We can approximately draw the structure of kaolinite, which is not important, but just I was trying to draw the structure. So AlOH bond O bonded to silicon, bond O bonded to silicon, then an OH connected to silicon, here also OH connected to silicon, and oxygen atom connecting silicon and aluminum, another oxygen connecting silicon and aluminum, that is 1 OH or aluminum. And now these two parts are similar. Leave it. Now coming to the ores of iron, we have hematite, HAEMATITE, Fe2O3 is the formula. Then magnetite, it is having the formula Fe3O4, it's a mixed compound of FeO and Fe2O3. Then for copper, the metal, the ores are copper pyrites. CuSFes is a mixed compound, written as CuFeS2. And malachite is also a mixed compound of hydroxide and carbonates of copper. It is also called a basic copper carbonate because copper hydroxide is basic. Now for zinc, the main ore is zinc blend, BLEND, ZNS. And then another ore is there, calamine, CALAMINE, that is zinc carbonate chemically. Now the entire physico-chemical processes for the separation of pure metal from its ore is known as metallurgy. So metallurgy is the process of isolation of pure metal from the ore. Now we employ various physical and chemical methods for isolation of the pure metal from the ore, and this entire process is known as metallurgy. Now an ore is dug out from the earth, so it will contain earthy impurities like sand and clay and small amounts of minerals of other metals. Now these combined impurities associated with the ore, that is earthy impurities and small amounts of minerals of other metals, are combinedly called gangue, G-A-N-G-U-E, gangue. Now the gangue should be separated from the ore first to isolate the metal. Now a maximum amount of gangue can be separated from the ore by physical as well as chemical methods. Now the separation of the gangue from the ore to a maximum extent is known as concentration of the ore. So metallurgy involved concentration of the ore, then isolation of the metal from the ore. That is the second process involved in metallurgy. Now there we use chemical methods, mainly reduction methods are used for isolation of metal from the ore, because most of the ores are oxides or sulfides of the metal, and the metal is found in a positive oxidation state, so we have to reduce the metallic parts. So that involved isolation of metal, and then during this process some minerals may also get reduced to their metals, so we get an impure metal. And for separating the pure metal from the impure metal obtained during isolation of metal, we use purification methods. So metallurgy involved 3 steps: concentration of the metal, which involved maximum separation of the gangue from the ore particles, then isolation of the metal by chemical reduction method mainly, then purification of the metal. Now coming first to the concentration of the metal. Now a major part of the gangue is isolated from the ore during concentration. Now the process is also known as dressing or benefaction. The ore particles are crushed to a particular range of size of particles before concentration. Now particles of proper size are prepared by powdering. Now there are sieves to isolate this powdered ore to collect particles of proper size. Now before a concentration, the ore is powdered to particles of proper size so that the process used may be effective for a concentration. Now the methods of concentration, first one is hydraulic washing. Now there the ore is placed at the top of a sloping surface. Now here the separation is effected by the difference in specific gravity or density of the ore particles and the gangue particles. Usually the gangue particles will be lighter, having low density than the ore particles. Now when a stream of water flows over the ore placed as a heap here, the lighter gangue particles are driven in the stream of water. So that causes a concentration of the ore particles. So lighter gangue particles are washed away to a maximum extent, not completely. Now this is called a hydraulic washing, and again known as gravity separation. Now the second method is called magnetic separation method. Now here the ore is magnetic and the gangue is non-magnetic. That is one possibility or the sponge is magnetic and the ore is non-magnetic. Now wolframite is an ore of tungsten, Tungsten, and it contains mainly tin stone, that is SnO2 as the sponge, which is a mineral of tin. Now what is done is, the ore is, powdered ore is fed to a belt which is rotating over two rollers, one roller here, one roller here, out of which one roller is magnetic, is a magnet. So this is a magnetic roller, itself is a magnet. Now the magnetic ore particles are attracted by this roller and will form a separate heap here. The non-magnetic impurities are driven away from this roller and it will form another heap. So when we feed wolframite, powdered wolframite over this belt running over the rollers, the wolframite ore will be formed as a heap below this magnetic roller, and tin stone will form a separate heap here. So separation is effected between the actual ore particles and the sponge particles, but here again there is no complete separation of the sponge from the ore is observed. Then an iron ore called magnetite, which is an oxide of ore of iron, is also separated by this method. So magnetite will form a separate heap below this magnetic roller. Now another important method used in concentration of ore is called froth flotation process, and here the sulfide ores are mainly concentrated by froth flotation process. Now some of these sulfide ores are galena, which is lead sulfide, zinc blende, ZNS, copper pyrite, CuFeS2. Now in a large tank, a suspension of the powdered ore is made. Now the tank is provided by the air supply and a rotating paddle wheel. Now a set of compounds called collectors are added to the water in the tank, and collector, one example for a collector is pine oil. Now this collector will preferentially wet the ore particles. So the collector will form a thin film over the ore particles. So they are made non-wettable by water. Now again, a set of compounds called stabilizers, examples are cresols and aniline. Now these stabilizers will stabilize the froth or foam formed during agitation of the mixture. Now when pine oil is added to the sulfide ore, powdered sulfide ore, and by the rotation of the paddle wheel, the mixture is agitated and air is supplied, so that a froth or foam will be formed at the surface of the liquid. Now here is the figure shown. We take ore, powdered ore and pine oil in a suspension of water, then it is agitated using a supply of air using a paddle wheel, then froth will be formed at the surface. Now the important thing is that the non-wettable ore particles are accumulated in the froth, and the impurities which are wetted by water will form a sediment at the bottom of the tank. Now, to stabilize the froth, we add stabilizers, and we have seen that aniline and chrysols can act as stabilizers. Now the froth is removed and dried. Now the separation of froth from the surface of the liquid is called skimming, skimming. So the froth is skimmed off and dried. Now if we have a mixture of sulfide ores, chemicals like depressants are added to separate these sulfide ores. For example, if we are having galena, PBS, lead sulfide, and zinc blend, that is ZNS, as a mixture, then a depressant, that is sodium cyanide, is added. Now the sodium cyanide will chemically react with the zinc sulfide, forming ZnCN 4 times 2 negative. It's a complex compound soluble in water, so that lead sulfide alone will be accumulated in the froth. So depressant preferentially separates one sulfide ore from the other. Now Zn 4 times 2 negative, the negative charge will be neutralized by sodium ions, so we can write it as Na2ZnCN 4 times. Now there is a chemical method for a concentration of the ore. Now that method is known as leaching. So leaching is a chemical process for the concentration of the ore. Now bauxite ore, that is aluminum oxide, ore of aluminum, is concentrated by leaching. Now the main content of bauxite is aluminum oxide, and it contains silicon dioxide and titanium dioxide as impurities or gons. Now what is done is the powdered ore is heated with a concentrated solution of sodium hydroxide at 473 to 523 Kelvin under a pressure of 35 bar, nearly 35 bar, and 1 bar is nearly equal to 1 atmosphere, or we can say 35 atmospheres or 35 to 36 atmospheres. Now under pressure and at high temperature, sodium hydroxide reacts with aluminum oxide and the gons silicon dioxide. Now aluminum oxide, one molecule plus 2 molecules of NaOH plus 3 molecules of water will give sodium aluminate. Now this compound is called sodium aluminate. It is soluble in water. Similarly, silicon dioxide will react with sodium hydroxide, forming Na2SiO3, that is sodium silicate, which is also soluble. So the solution is filtered to remove other gonges, and then the solution containing mixture of sodium aluminate and sodium silicate is treated with carbon dioxide gas. Then sodium aluminate alone will react with carbon dioxide. Carbon dioxide is an acidic oxide, and sodium aluminate contain hydroxy part. So the reaction will result in formation of aluminum oxide 2H2O plus sodium bicarbonate. So you can study this equation by heart. 2NaLOH 4 times plus CO2, 2NaHCO3 plus Al2O3 2H2O. Now hydrated aluminum oxide it is called. Now this hydrated aluminum oxide is heated strongly to give anhydrous aluminum oxide. Now then this anhydrous aluminum oxide may be taken for isolation of metal by reduction, and then the aluminum forming may be purified. Now other examples of leaching. One speciality of gold and silver is that they are least reactive, or they are noble metals, we can say. So they are found as such in nature, or they are found native in nature. But again they will contain minerals of other metals. earthy impurities like sand and clay. So we have to separate these gonjas from the metal, and for this the process used is called cyanide process. Now what is done is the ore containing silver or gold is leached with sodium cyanide in presence of air. So the reaction goes on like this: 4Ag plus 8Cn negative plus 2H2O plus O2 giving 4AgCn twice negative plus 4OH negative. So that gold alone or silver alone will dissolve in cyanide in presence of air as sodium argentocyanide or sodium oreocyanide solution. Now then it is filtered and the filtrate is treated with zinc. Now zinc will replace silver or gold from this complex as Ag or Au. So precipitate of silver or gold will be formed. Now these are redox reactions. First of all, Ag will be getting converted to Ag positive. So one electron will be getting removed from Ag. Then O2 is converted to O2 negative. Since there are two oxygen atoms, 2 O2 negative is formed, and for that we require 4 electrons. 2 into 2, that is 4 negative. So 4 electrons are needed. And Ag, when converted to Ag positive, only 1 electron is removed. So to get 4 electrons, we have to multiply here by 4 and here by 4. So we require 4 Ag, and of course 1 O2. Then 2 O2 negative will combine with the 2H2O to produce 4 OH negative. So here 2H2O, then 4 OH negative. And 4 Ag positive will react with 8 Cn negative, giving 4 AgCn twice negative, where silver is in the +1 state. Now again, the reaction with the zinc and AgCn twice negative. Now here the negative charge will be neutralized by Na positive. That is understood. Here also the 2 negative charges will be neutralized by 2 Na positive. So Na2 is then Cn 4 times. That is be the complete formula. Now here again Ag positive is getting converted to Ag in the 0 state, and Zn0 is converted to Zn2 positive. So that here we require here 2 electrons are removed from zinc, and here for Ag positive to get converted to Ag0, 1 electron is needed. So to make here 2 electrons, you multiply this by 2, and again here you write 2. Then the equation is balanced, so that 2 AgCn twice plus Zn giving Zn Cn 4 times 2 negative plus 2 Ag. So that is the leaching method, which is very important: leaching of bauxite and leaching of gold and silver ores. Now if you replace Ag by Au, that is symbol for gold, then you can complete the equations for leaching of gold ores. Then you repeat these equations using Au instead of Ag. So that is leaching process, concentration method. I am stopping here. Thanks for listening me.